Imagine you have a coin and you flip it twice. For example, you get heads twice. Then the probability of tossing heads is 100% and of tossing tails is therefore 0. But if we now toss this coin 10 times and get 7 heads and 3 tails, the probability of heads is 70% and tails 30%. If we now continue this up to the number 1 million, so 100, 1000, 10,000, and so on, we can see the following. For example, if you throw 100 times, the chance of heads being 64% and tails being 36%. If you toss the coin 1000, the probability of heads is only 56% and tails is already 44%. So you can see that the more throws you make, the chance of heads or tails gets closer and closer to 50%. But why is that so? Why is the chance for head, for example, getting closer and closer to 50%, and why will it never be exactly 50%? For an infinite sequence of coin tosses, according to the law of infinite numbers, heads and tails are very close to the relative frequency of 50% in the long run. The graph shows with the yellow graph how the percentage of the head changes depending on the number of throws. The same is shown in the blue graph, which is supposed to represent the tail. The red line is the 50% mark, which the two lines are getting closer and closer, but never touching. This once again illustrates the law of large numbers. If you throw heads 10 times in a row, the next roll is still at a 50 to 50% chance. The chance of this happening is 0.5 to the power of 10 or 0.00097656225%. But what happens if we flip a coin 1 million times? We wrote a program for this so that we don't do nothing but flip a coin for 30 days. The result of flipping a coin 1 million times is 499,647 times tails and 500,353 heads.